A very good afternoon, everyone. Thank you for joining. We have a great topic to cover today, but before that, a few notes. This session is recorded and will be made available on Alibaba Cloud Southeast Asia YouTube channel. All the links and the demo code are also made available on my GitHub page. If you have any questions during the session, please feel free to ask by typing them in the chat section, chat box. I have with me today my colleague Chuck. He heads the architect team and he will assist with answering your question during the session. And if you want to reach me after the session, please drop a message on LinkedIn. I'll be happy to follow up. A brief, a brief intro about me. I enable business in the adoption and acceleration of cloud native practices. Though I do not manage infrastructure on a daily basis, I have in the past and now involved in the value chain, either as a developer requesting for resources or as an architect designing enterprise solution, and as well as a product manager for SaaS application. A brief about the company I work for. BigMind provides specialist services and software tools to help business in their cloud native journey. There are three main areas of focus. The first one is discovery workshops, where we run a 1 to 3 day program to help business solidify their use case and create action plans. Second, we provide advisory and implementation services to help bring cloud native projects live. We also provide half a day acceleration sessions to help development and operations team in specific area of focus. We discuss challenges, pain points, identify potential pilot projects to get things moving. Finally, we also produce cloud native tools to help simplify advanced Kubernetes use cases. So in today's session, we will look into infrastructure as code, specifically about using Terraform to orchestrate infrastructure on Alibaba Cloud. And when preparing for this webinar, I wanted to include a few advanced topics like working with variables, Terraform modules, and workflow. But then it won't be well appreciated if you haven't tried the basics. So I wanted to keep this webinar very simple that everyone joining today can subscribe to the services and try out without any prior experience. We could cover the more complex scenarios in future webinars. So if you're new to the topic, this session will be very beneficial. I will share with you the basics of infrastructure as a code and why Terraform is an ideal tool, followed by a hands-on demo where we will learn how to easily automate your deployments. I will also be sharing some of the enterprise scenarios where infrastructure as a code makes a greater impact. The demo is going to be very easy to understand. You do not need any prior experience in coding or any tools or any command lines. The sample code is available on my GitHub page. So all services shown today have free tier subscriptions, so you can definitely try. So at the end of the session, I believe that you will give it a try, understand the ease of use, the benefits, and be a catalyst for change within your organization. So let's start with the question why. Why do we need infrastructure as a code? Very simple, the customer expectation. To keep up with customer demands and competition, businesses need to deliver value to customers faster and more frequent. So with technology-driven products, this means making shorter feature release cycles, which equates to multiple build, test, and release activities in a very short duration of time. So to facilitate this, you are required to spin off temporary testing environments and continuously update the production environment. And this is a challenge that the infrastructure code is addressing. It is so as a simple definition for infrastructure as code is it's provisioning infrastructure through software to achieve consistent and predictable environments. So these environments could be your public cloud, it could be your private cloud, data center, hybrid or multi-cloud environments. The key term here in the definition to look out for are one, software. So we use a tool and not a manual process, similar to writing a C# or a Java code and then using a .NET runtime engine to execute. So here we write infra code and use a tool to execute. The second important element here is the consistency. So no matter how many times you repeat, the provisioning happens the same way every time you run the code. And this means you always get a predictable environment. The environment will look exactly like what you defined in the code, and there will be no drift from it. So that's a fundamental of infrastructure as a code. So this brings the question, does it mean I need to learn to code? The answer is no. These codes are represented in a human readable format like YAML, JSON, or HCL, the HashiCorp configuration language. Similar to other programming languages, there are compilers that will compile and execute these codes. However, in this case, it is not that complex as writing a Java or a Python code. There are primarily two approaches to implementing these codes. The imperative way, this is like your command line scripts where you write procedural code defining every step to reach a target state. Many of you would be familiar with writing shell scripts or PowerShell scripts. The imperative code so these are type of imperative code approaches. Another approach is declarative. This defines the desired state and the system executes what needs to happen to achieve the desired state. This is what you commonly see in modern automation tools. In some cases, the procedural code might look simple. However, the challenge is when you want to make a change. So let me give you an example. Let's say you want to add a tag to an existing VM and say that this classify them as a dev workload. Or you want to allocate a new IP to your existing VM. You will need to write a new command in a procedural approach, right? And if you modify the existing commands and execute, you will receive an error stating that the resource already exists. So that's a problem, and you will end up with creating multiple scripts to get what you want to achieve, right? So in the case of declarative approach, you just add a tag to the configuration. So you just edit the existing configuration file, just add that line to say, hey, this VM is tagged as a development VM, right? And then you define your end state. The system will check what is the difference between your desired end state and the current state of the infrastructure and applies only those changes alone. So next, let us look into the benefits and understand why you should consider defining your infrastructure as a code. To start with, you can automate your deployment. So no more manual step every time a service request comes your way. You get more time on value-added tasks and spend less time repeating deployments. You can repeat the deployment any number of times and can be confident that every time you want to create an environment, it is going to be the same and consistent. So there will be no missing steps, meaning no troubleshooting. For example, you want to create a test environment frequently for your QA team, or if you are a software vendor who needs to create multiple environments of the same product for your customers. So that works handy for those situations. Other benefit is that you can create reusable code like modules and reference them in new deployments. Teams who are specialized in certain platforms or business units like security can contribute and collaborate with the wider group. For example, if you take Terraform, there's a registry with modules developed by cloud providers, and you can directly reference to those in your code. So you do not have to reinvent the code. With version control, source control and versioning, you can now associate your deployment plans to the versions of the underlying app. So there will be times when developers want to test an older version of the app and need an environment specific to that version. Traditionally, you may manually create these on demand, or you will just leave multiple versions of the infrastructure running at all times. So this is going to be expensive. So to better manage time and cost, you can now have these environments provisioned and destroyed on demand. So having a version control also means that you can tag the infrastructure changes to the feature release. And most importantly, you can now document your infrastructure. For example, you could add a comment about why a specific port is open, or the classification of resources in a subnet, or a change that was made specific to a service ticket. So you can add all these comments to the code. Coming to the business benefits, like any other IT investment, stakeholders are not going to support new initiatives if there are no visible benefits. So it's very important to understand and plan your metrics accordingly. So consider so firstly, by automating, we save on time. It now takes very little time to create infrastructure, and it reduces the waiting time and therefore improves the overall developer velocity. Consider the traditional approach. Your business may require you to develop and release a new feature. The app team requests for a multi-tier test environment, and this request would usually go to a service desk, waits for approval, then gets provision, and by the time it reaches the dev team, they have a new change to make. So you could automate this entire process with pre-configured policies, security checks, and approval. Business can also reduce the downtime on applications or on infrastructure updates. In the event of disaster recovery, you can spin off a new environment faster and improve your SLA. Infra teams can now invest their time in more important tasks. Similarly, integrating with other DevOps tools will also enable a higher velocity and agility. The second factor is the cost savings. Apart from the overall reduction in effort, the business can also reduce costs by only creating environments on demand and destroying after use. For example, the test environments, you do not need them running always. By avoiding manual patches on environments, you also reduce the technical debt and associated future costs. It lowers the risk of creating unstable environments and avoids possible breach of service levels. Thirdly, we can improve the quality by creating consistent environments. This means fewer errors with automated processes. It is now easier to adopt best practices, collaborate, scrutinize, improve security, adhere to compliance, and makes it much more easier to audit. So with reduced time, reduced cost, and improved quality, business can now deliver better customer experience. As with any other new technology, there are always challenges. So, from my experience, one of the biggest challenges is the organizational mindset, the resistance to change. People are comfortable with the current process or occupied with business as usual. In these cases, it is important to evangelize the benefits, highlight the risks, generate interest, and try in small groups, maybe a proof of concept, and eventually you will be able to get a wider acceptance. Your current situation may not be as simple as what we are looking today, but the first step is very important. Explore some of these products and continue to learn and improve. I have made today's demo very simple to get the ball rolling, and I believe everyone will give it a try. Every cloud provider has some form of automation tools. On Alibaba Cloud, you can automate using command line scripts or using resource orchestration service. This is a fully managed service, and you can use templates like JSON and YAML formats to describe your configuration of resources and also the dependencies between these resources. These templates automatically deploy and configure all the cloud resources across your accounts and across the regions. Uh, if you are adopting a multi-cloud strategy, they also support Terraform. Alibaba Cloud has a new cloud shell with Terraform modules integrated, making it much more easier and convenient to create a code. Other options here include Ansible, which also supports provisioning resources on Alibaba Cloud, and it's also very well matured. However, together with Chef and Puppet, they are primarily classified as a configuration management tool, which is to configure services like web server, IaaS, Nginx, and your applications that run on this infrastructure. So we will not touch on the configuration management tools today, but if you are keen to learn more, drop us a feedback. We'll be happy to follow up in future webinars. So that completes our first section on what infrastructure as code is. We looked at the benefits, the challenges, and the available solution. So let's now move on to the next section on Terraform. As a tool, Terraform is very easy to use. Just download a single binary, no installation required. You can just start using it. You will use HashiCorp configuration language to write the code. It's a declarative language and it's very easy to learn. It allows grouping of resources as modules and makes it very convenient to reuse across projects and organizations. There's a public library of community modules from partners, contributors, and HashiCorp themselves. Terraform has support for over 200 providers across cloud and on-premise setup. I see a growing trend in businesses spreading the infrastructure across multiple clouds, primarily to increase the fault tolerance. Multi-cloud or hybrid deployments can be very challenging if you are only to use the cloud provider specific tools. Terraform is a very cloud agnostic and also a single configuration to use to manage multiple providers. So you only need to learn a language to write the code. If you are on a multi-cloud strategy, Terraform comes in very handy. With growing popularity, there is support for native integration with many of the enterprise and DevOps tools. For example, Terraform integrates well with configuration management tools like Ansible, Chef, Puppet, with version control systems like GitHub, GitLab, Bitbucket, Azure DevOps. There's integration for with Sentinel for policies. It has an integration with ServiceNow to self-service your infrastructure requests. There's cost estimation module for specific providers. Based on the end state, Terraform will provide an estimated cost before you make that before you deploy the resource. So you can so you can review the cost before the deployment. And most importantly, Terraform takes the approach of plan and apply. So the planning step is where it generates an execution plan by determining what actions are necessary to achieve the desired state. You could then review this plan and choose to approve or reject the execution. This lets you avoid any surprises. Dependencies are also well taken care of. If you have a multi-tier infrastructure, Terraform will ensure that the database tier is available before the other servers are started and followed by the load balancers. So it can take care of this dependency nicely. So next, let's look at the components involved and how Terraform works. There are two main components to understand here. One is the Terraform core, which is the software that executes your code. There is an open source version, which is widely used and written in Go language. We will look into the other managed options of the core in the upcoming slide. The other important component here is the Terraform plugins. These are the providers that the core application will interact with to provision your infrastructure. So developed together with cloud providers like Alibaba, Azure, VMware, the plugins provide an API for execution. All we have to do is to define the desired state of our infrastructure in the configuration files and trigger the execution. Terraform core will read the file, identify the provider, and it will then communicate with the provider API and orchestrate the resources. All of these are abstracted and you do not have to worry about how it's executed. The first time you execute the code, Terraform creates a state file to store the metadata about the infrastructure. It's a sort of a database to map the configuration to the real world. So prior to any operation, Terraform does a refresh to update the state with the real infrastructure, because Terraform is more like an agentless. It doesn't really keeps your state in sync. So every time you execute a plan, it does a refresh of the state. It's a JSON file, but word of caution, do not mess around with it. It's generated by Terraform. Just leave it. If you change, things are for sure going to break. By default, if you run the code from your local machine, the state file is also saved on a local disk. But when working in teams, you may have team members making changes to the same environment and also triggering the run at the same time. In enterprise scenarios, you will have a CI/CD pipeline that will trigger the run. So you will need to share the state file. The most common approach is to save this file in an object or a cloud storage and apply access restriction. This is called a remote state, and Terraform can use locking to prevent concurrent runs against the same state. One thing I want to highlight here is the immutable infrastructure approach. Where possible, Terraform will make change to the existing infrastructure. Otherwise, Terraform will destroy and create new resources. As businesses move towards automation and minimizing all manual intervention, it is a common trend to create new machine with the latest version of the software than applying patches to an existing one. But if you have to re-architect the application, but you may have to re-architect the application if you're storing files locally on the server. I'm not going to go into the details, but if you are new to this approach, I recommend to read about the benefits and trade-offs of the approach. If you're a beginner, then start with writing all your code in a .tf file. It doesn't have to be main.tf. You can name it whatever you want. A TF file is where all your code will belong. As you start using, you will see a lot of repeating values like region, project name. So to be efficient, you can group these variables within the same file. So for example, you can see here the box. So there's a variable for VPC name, and when you create the resource, you can just use those variables. So as your infrastructure gets complex, you will start splitting them into modules and will have multiple config files under the same directory. It's common to move the variables into a .tf vars file. It works well if you have different environment variables for your dev, test, stage, and production. So let's say, for example, you have one set of VPC IP addresses, region, or a project name for test, another for production environment. This you could use the variable file, and that will be much efficient. And remember, do not touch the TF state file. So commands, Terraform commands, there are 4 common set of commands. You initialize your environment based on the provider. So that's a Terraform init. And then you plan the execution using a Terraform plan command. And then you review and apply the config. And where required, you will then destroy the environment. The destroy command will clean up the environment, commonly used for temporary setups like test, or if you're conducting a disaster recovery drill. After you set up the environment, you're likely to destroy it. So those are the 4 commands: init, plan, apply, and destroy. That's all you need to remember. So what are the options we have with Terraform core? So there are a few options to use. The common and the most widely used is the command line, the CLI. It's an open source and free to use. You download the executable and run. It's very easy and straightforward, but you need to take care of the state file yourself, and you also need to take care of integrating with existing system. So being local, this being state file being local, makes it a little bit difficult for sharing or collaboration within your team members. So that's going to be a little bit tricky. So if you're new and trying this for the first time, I would suggest to go with Terraform Cloud. It is a software as a service product managed by Terraform, and there is a free tier. So with this option, you get a nice user interface to execute and configure your triggers. The state file is stored and managed on cloud, and it's very easy to collaborate with team members. I believe the free tier allows you up to 5 team members. Yeah. So alternatively, if you are an enterprise customer and want to integrate with existing tools and require more advanced functionality, then you also have a self-hosted version of Terraform. With Alibaba Cloud, Terraform is part of their DevOps solution, and there's a great support and contribution to the modules registry. You can browse for sample code and reference it directly in your code. If you do not want to use the CLI or a Terraform Cloud, they also have a web interface, like a Cloud Shell, to execute on Alibaba Cloud Console. So in this section, we discussed about Terraform, how it works, file formats, the options to execute. Next, I will run through a demo and let us see it in action. So what I have planned for today is to show a workflow where you may experience within your organization, let's say you have engaged a vendor to develop a web application. The AMP team is requesting for a virtual machine to host it. You as an admin decide to isolate the network, so you create a VPC. Excuse. You create a VPC with a subnet to host it. The subnet to host the VM. A VPC is a logical isolation of a network on a public cloud. So for the purpose of the demo, I will not be creating the actual VM because it takes few minutes to provision, but you could always try this yourself. So let's say you start with a simple VPC and the subnet. After a week, your security team reviewed and they advised to move the web app and the TP into multiple tiers. So the app team is now requesting you to create multiple subnets to host the VMs. And based on your past experience working with app and vendor teams, you are very well aware that the frequent requests and there are always frequent requests and changes to the environment. So let's see how to automate this using Terraform and Alibaba Cloud. For this demo, I'll be using GitHub to store my code. So every time there is a change in the code, Terraform Cloud will be able to detect it and plan the execution. You will then be presented with the logs to review. And once you review and approve, the resources will be created. So that's the workflow we are looking at. Make your code changes, commit to GitHub, automatically trigger the run on Terraform Cloud, followed by deployment on Alibaba Cloud. All these tools have free tiers, so please do subscribe and try. Yeah, so if you're new, just go to GitHub. You have a free plan. On Terraform, you could sign up for the Terraform Cloud. There's a free tier there as well. And on Alibaba Cloud, you also have a free account. You could create a free account. There's some credits. But if you're going to follow this demo, you don't. I'm just going to create a VPC and stuff that which really doesn't. I think it's free. Only if you're running a VM, then there is a metering for it. So let's go back. So in terms of prerequisites, let's start with some preparation. The first task is to create an access for Terraform to execute the code on Alibaba Cloud, right? So when you sign up on Alibaba Cloud, you're given an account with the identity and access management. You can use your own username and password for Terraform to access cloud, but this is generally not advisable because this is your main account. So what we will do is to create another user called Terraform or an API, and then create an access key. With this, you are in complete control of the access. So you can revoke the access or you can change the key. So let's go and start with that first step. So once you sign up to Alibaba Cloud, you get your console. This is the main console at the dashboard. Just go to the search, and it's very easy to kind of access all the services from here. Search for RAM, which is Resource Access Management. So it will open up a new console. This is your identity management. So on your left, you see users. Let's go to the users and create a new user for Terraform to access. So I'm just going to call it just that PF webinar 002. Right. So you see there are two options to access. One is the console, which is this UI, and the other is a programmatic access. In our case, Terraform is going to use the API. It's not going to log in on the console, so let's just only select the program access. And once you create the user, you will see that it created an access ID and access secret. To make a copy of this, because you you can't come back and look at the access secret again. So you need to recreate the secret. So make a copy. I'm gonna paste it onto a notepad first. Yeah. So the next step is to give the permission for this account to be able to create resources. So in your organizational use case, you may restrict the access to specific resource groups or specific regions. But for the sake of this demo, I'm just going to give the administrator access for this use. All right. So that's it. So we created a user. We gave the permission to create resources, right? So the next step, let's go and create a GitHub repo where we will then create our Terraform code. If you're new to GitHub, just register and you will see a new repository. Let's call it as webinar 2. Just keep this private. Just make sure that you select this add a readme file, because if there are no files when we try to connect from Terraform, it will show an error that the repository doesn't exist. So ensure that you create a readme file. And that's it. Create a repository and should be good to go. So we have a repository where we can create our files. Okay, let's also configure a Terraform workspace. So go to terraform.io, sign up for the cloud. Remember, it's Terraform Cloud, not the Terraform CLI over here. And you will see new workspace. So the workspace is like an isolation. It's like a project. So you could classify for this project a new workspace, or for an environment, you could have a separate workspace. For a test environment, you could have a separate workspace. There are patterns on how you want to orchestrate your repository and workspaces based on your usage and how frequent you make changes and how many environments you do. But in this case, yeah, just create a new workspace. The first thing what we want to do is to tell, hey, Terraform, here is my GitHub. The first time you click this button, it's going to ask you for access. Just allow the access for Terraform to communicate with GitHub. So I'm selecting this GitHub repo. Good. So what Terraform is doing is it's trying to reach out to GitHub, to that particular repository, and check if there are any configuration file. It just takes a few seconds to verify. Great. So what we have done is we have configured Terraform to communicate with the GitHub repo. The next step, what we want to do is Terraform to be able to communicate with Alibaba Cloud. So if you remember the previous step that we did where we created the access key, we will need to enter those access key and the secret as variables in Terraform. So click on the variables. It's always here. You could go back, go to the environmental variable, and let's add. I'll later show you the registry where they define which are these access keys. You need to follow the naming convention. You can't change that. It needs to be the same. So the access key is the kind of the user ID, right? Yeah. So you could select this as sensitive so that it doesn't display on the UI. So the next is the secret. And that's one more, which is the region. So since I'm connecting from Singapore, this is the region code. You need to use the same code. Right, that's all good. Just to check if it's able to access the GitHub again, I'm queuing up the plan. This is going to show us an error because there are no configuration files over here. Yeah, so it says setup failed, no configuration files. So let's go and create the file. So on your repo, just add file and create a new file. Let's call this name.pf. Right. So the first section is we need to define in our code which is the provider we want to access. So in this case, it's going to be the cloud. And the next block that I want to create is the two resource. Okay? So if you look at the structure, it says I need a resource of type VPC, and this is the ID or the ID for the resource that I am providing. And inside I'm saying this is the name and use this IP range for the VPC. And here I'm saying that I need a resource of type vSwitch. A vSwitch is a subnet classification in Alibaba. And this is the ID. And over here, what this means is I'm saying that for the subnet, this subnet belongs to the VPC. So cloud VPC, the VPC to right. So that's how the dependencies are managed on Terraform. That's it. That's all the code. So what we do is we're going to commit this file. So we say VPC and subnet. And let's commit the code. All right. So if I go back to Terraform and hit the run, you see that it has automatically triggered a planning. This is because there was a code change on GitHub that triggered a webhook on Terraform, and it has started planning. So let's look at the logs. Yeah. So it has gone through the code, and it's saying that there are two resources to add, nothing to change and nothing to destroy. All right, and all good, no errors. So the planning is finished. It says it needs a confirmation for me to apply this to the cloud. So I'm just going to go ahead, confirm and apply. Maybe before that, let me show you the VPCs before we. So let's look at the existing VPCs before we deploy the new one. Just have two VPCs here. Okay, so let's go and confirm this plan and have it applied. So it's initializing the Alibaba Cloud plugins and modules, and it's creating the resource. Right, so the apply is finished. Let's go refresh, and we should see. Yep. So this is the new VPC that we just deployed. Right. So what we did is we just defined the code, and then Terraform automatically picked it and deployed. So you remember there was a confirmation here that I need to say, okay, proceed to apply. But let's say you're using this in a pipeline or for a test environment where it's already pre-defined, so you don't want to do this manual approval. You could completely automate the process. So just go to your settings and general settings, and you will see that there's an auto apply and manual apply. So let's select the auto apply, which means if you change the code on GitHub, Terraform will automatically pick up and it will plan. If there are no errors, it will just go ahead and apply it to the cloud. So let's do that. Let's go change our configuration to create the 3-tier, right? So we looked at, yeah, so what we did is we created a VPC and a subnet called web app. Now let's go and update the web app to just web and create 2 more subnets. Okay, let's edit the file. So I'm just going to replace this piece of code and just change the name to web and created two more. I said no other change. Just saying create the subnets. All right, that's done. So if you come back to our workspace, and you see that it has triggered because there was a commit on the code. Code was changed, so the planning is happening. Yeah. See, you over here, you will see that it has identified it. But let me just expand this a bit so you can see that. So it is creating a new DB. It's creating a new subnet web. And it's destroying the previous one. So this is the immutable approach that I was talking about earlier. It will just destroy the old one and recreate the subnets and reattach the resources to that subnet. And this time it didn't request for any approval. It just went for the auto approval. So, right, so that's all done. So let's look at the VPC. So previously it was var, and now you see that it has created the piece of that subnet. So it's created a subnet DB. Right. So I hope you get an idea of that entire automation workflow, right? So we just made a change on the where it automatically provisions code. So I believe that's pretty straightforward. If you go to my GitHub page, I've created a repo for Terraform Alibaba Cloud getting started. You will find this sample code as well as a very simple documentation. If you want to change the region, I have links for you, as well as how to create the access key. And if you need to create other resources, there's also a link, which is the registry where all the modules are there. So you can go and check that out. So let's say you want to create a CDN, just go to the CDN and you have the code here. So just copy this code, put it into the config, and it's all good. Let's do one more step where we want to destroy the infrastructure. So instead of going to cloud and then individually deleting the resource, what you could do is click queue your destroy. All right, so yeah, so that's going to queue up and destroy the infrastructure. Just give it a few seconds, and that should be all good. There are also examples on GitHub from Alibaba Cloud, so you can try that out. So this is maintained by Alibaba Cloud team. So there's a lot of examples and modules. You could directly reference these modules. So yeah, just link. You can reference this TF file from your configuration, and things will work the same. All right, that's good. So the destroy plan has been applied to the cloud. So if I go to the VPCs, yeah, it has removed the VPC that we previously created. All right. So next, let's look at some of the practical use cases. Yeah. So as the complexity grows and the governance and policy kicks in, you want a more robust process, right? You can create this as a pipeline of activities. So when a code is changed and a commit is made to the version control system, a plan and apply for the test environment can be triggered. Automated policy checks, security checks, cost estimation, or vulnerability tests. All this can be automated, and the report can then be sent to the admin or the ops team or whoever is doing the review. And once they reviewed and approve another plan and apply for the production environment can be triggered. This will then deploy the requested changes to the production environment. Another use case is a disaster recovery. If you want to minimize the cost of infrastructure and can afford a lower SLA, you may choose to run an active, you may choose not to run an active secondary standby region. So on a normal day, what you do is all your code changes are applied to the primary region. You can then use an enterprise backup and recovery solution to schedule the backup of app and data. If you have a Kubernetes clusters, I strongly recommend checking out our product Cape, which makes it very easy to schedule backups. It supports multiple cloud providers and also provides you with the granularity of selecting individual namespaces and apps. But to make sure that the backups are stored securely in another region or another cloud provider. And when disaster happens, you can trigger the recovery process. Now that you have Terraform, you can easily automate the infrastructure deployment on a new region. And you can be very confident that the end state will be the same as the primary. And so once the secondary region has been deployed, you can then go and recover your applications to the region. Another use case using Terraform is a migration. So you may want to migrate from your on-premise setup or any other public cloud provider to Alibaba Cloud. The first step is to analyze your current infrastructure and create a target state architecture. And based on that, you can create a Terraform code to provision the infra. So you could use Cape or any other backup tools to create the app and data backups, and you can then recover those on Alibaba Cloud. So what if you have a Kubernetes clusters running across multiple providers, and how can you manage the app and infrastructure? So what you could do is you could simply use our product Cape to manage those app deployments. Point your delivery pipeline to use Cape, and based on the providers defined, Cape will take care of deploying the applications to the cluster of the respective providers. If you're interested to know more about how to deploy, manage, and secure your Kubernetes apps and data with ease, do try out our product at cape.sh. There's a free tier, so you can try out in your existing Kubernetes clusters. So this brings to the end of this session. A quick recap of the topics we touched. We started with the basics of infrastructure as a code, why we should consider it, what it is, what are the benefits and challenges. Next, we looked into Terraform, a popular tool for automation, followed by a demo where we saw how to automate the creation and updating of resources on the cloud using Terraform. And we concluded with some practical use cases to consider. As a next step, I believe you will give it a try yourself and get familiar with the products. To help you with the continued learning, Alibaba provides online and instructor-led training. There are also certifications to follow up. Similarly, Terraform provides online learning content, and you could take the infrastructure automation cert as well. It's a infrastructure associates, I believe that's the name. If you have a specific use case, a challenge, or looking for expert advice, do reach out to us. Happy to have a session with you to understand more and advise you on your journey into cloud native. And if you have any questions, please drop them in the chat section. Let me check if there are any pending questions. I believe Chuck might have answered most of those. Yep, so the recording will be available. We will update the link. You could also go to the GitHub page that I was showing you earlier. I will update the link there as well. The slides will also be will be shared on SlideShare. I will also update the GitHub page to reflect the link, so you will be able to get that. All right. Let me just go to. So just look out for this GitHub page, and I will make those changes. Probably I'll also update. I'll make a post on my LinkedIn when the recording is made available. So the code snippet is here. So just go to github.com/envelope-net. Yeah, please do give it a try. I mean, I have really tried to make it very simple with the only purpose of having more people adopt and have the practices implemented in the organization. So yeah, give it a try, share with your colleagues, try something simple, gain your confidence. I think that should really help. I'll just wait for another few minutes and then we'll end. In the meantime, if you can share with us in the chat window what are the tools, what are the current tools that you use in your organization, I think that would be great. We can look at what kind of webinar topics to run in the future. If you have any suggestions, also drop in the chat box, please. All right. So great. Thanks again, everyone, for joining the session. Have a great evening. Bye-bye.